showing advanced properties, so that this is used for the different types of application. Now applications are starting from your home to the space, up to that level in the defense field, space field. Okay, so there are so many applications. Okay, that applications also we are going to see in upcoming chapters. But simple definitions, if anyone will ask, very simple definition of the plastic is that material that can be reshaped by application of heat and pressure. Material that can be reshaped by the application of heat and pressure. Right, now let's segregate this particular statement. Right, so material that can be reshaped. Okay, now let's work up to this only. Material that can be reshaped. Now in this case you will see so many other materials that can be reshaped. Okay, let's take an example of your mild steel. It can be also reshaped. Okay, because see, you know the applications of mild steel. If you see in a building structure, they are using the mild steel as a mild steel bars for a fabrication purpose. Entirely mild steel is used. Okay, there are so many categories in the mild steels. There are so many different varieties of the steels, based on the carbon content, based on the aluminum content, based on the zinc content. Depending on the percentage of different materials, there are so many varieties of the steels. Okay, so this steel also can be reshaped. Okay, now if you see the iron ores, if you see the iron ores, they will they really will there you will get the concept of reshaping the steel. If even if you see the major application in the railways, because the most of the structure of the railway, starting from the railway engine, railway bogies, railway track, mostly this is manufactured from the steel, right? Because in another cases we have seen aluminum also, sheet metal also, but in case of railways, because of the huge load capacity, it is mostly manufactured from the steel. Okay, starting from the basic railway tracks, which we call it as the rails. Right, if you see that rolling mills, that rails are made through the rolling mills. Okay, so first of all, there is used to be a billet. Billet is a large size, uh, that steel bar, rectangular shaped large size bar, that is called as a billet, and that is passed through the roller, and the rollers are of the shape of rails. So heated rollers are there, and that particular bar is passed through the roller, and you will get the rail tracks. Okay, here also reshaping is there. By this reshaping, you will get different kinds of structures, different kinds of shapes of the steel, and that is used for the different types of applications. Okay, and if you see the properties of the steel, these are um, more advanced rather than plastic. Okay, very simple example I will give. Honda. Okay, now previously it was a Honda, then it has merged. Then they have started the working with the collaboration with the Hero. Then it was emerged as a Hero Honda, and now again it is splitted, because you know that now currently Hero is different and Honda is different. Okay, just 3 4 years back they have split it. But there was a one two wheeler. Okay, you will see that in villages also nowadays. But now Honda is not manufacturing that. That is called as a Hero Honda CT100. Right, Hero Honda CT100 and Hero Honda CT100 double S. You have seen that particular two wheeler in villages. That two wheeler is present now also, which was manufactured more than 50 years ago. And if you see the structure of that particular two wheeler, again I will repeat the name, Hero Honda CD100 and CD100 double S. Okay, if you see the structure of that particular vehicle, mostly 95% parts are made from the steel. Okay, and so the see the life of that particular wheel. Currently also it is available in a good condition, right? But what is happening? What was happening that whenever that hero when that particular hero Honda was manufacturing that two wheeler, most of the time they have found that it is not coming back for any type of maintenance, because more uh, best will be the structure. It will not have more maintenance. So that after that they have stopped the production of Hero Honda CD100 and CD100 double S. Because see how the companies will work. If you will sell the product which can be used for 100 years, then how companies are will run? How the companies will run? No, your product should be such that let it be. If it will there for 100 years, but at least it should require maintenance after some time, so that that particular customer will come back to the company, and that's how they will get their business, isn't it? But if the product is such that once you will sell that particular product, neither customer is coming back nor the product is coming back, means it is having a very good life. So in that case the company will not have business. Okay, so that they have stopped that particular production. But structure of steel was, whatever the steel they have used at that time, it was so nice that it was there for so long time. Okay, now take any example of any two wheeler which is used nowadays. Let's take the example of Shine. Honda Shine is there, TVS vehicles are there, Hero vehicles are there. If you take any of the two wheeler, what I told in case of Hero Honda double S, that 95% parts are made from steel. And if you see current day, any of the vehicle, 95% parts are made from plastic. Now, it is not a pure plastic, composites, okay, fiber reinforced plastics are there, different types of plastics, okay, but it is the application of the plastic or variations of the plastics. So that this has changed that way. Okay, if you see even in a four wheeler also, large capacity vehicles also, there also you will see the application of plastic at a having a very huge percentage of usage of that particular plastic, right? So it has used so now that application of the plastics are increased heavily as compared to the old days. Now here are the two things which are responsible for that. One is a heat and another is a pressure. One is a heat and another is a pressure. What is happening? See, if you take any of the plastic component, and if you want to change the shape of that particular component, it's very easy. It's very easy. Okay, now let's be now interactive. Suppose I will have, forget about the plastic, I will have any of the component, any component made from any another material another than the plastic. If I have to change the shape of that particular component, if I will have to change the shape of that particular component, what are the possible ways? What are the possible ways? Suppose any material you can take, any material you can take. It may be wood, it may be steel, it may be plastic, it may be stainless steel, it may be mild steel, it may be composite, it may be fiber composite, it may be RCC. Okay, so whatever material you will take, there are two basic ways to change the shape of the material. First is by using heat, and second is by using pressure. Getting it? First by using heat and second by using pressure. Now, in some cases, you can easily change the shape of the material by using the heat. Okay. Now, now tell me, if suppose I will have a steel rod, a rectangular steel rod or a cylindrical steel rod, and I have to change the shape of that particular rod. Shape in the sense I have to make it round, I have to make it in a triangular shape. What are the options? Have you seen any of the construction site? There they are making, right, different shapes they are making from the steel bars. They are making the triangles, they are making the like U-shaped bars. How they are doing? Have you seen that? They are not using heat there, they are using pressure. Simply by applying huge pressure they are changing their shape. And if you see in case of the example, like I have given you the example of rails, railway tracks, there it is not possible simply with the pressure. You need to have the application of heat also. Getting it? Application of heat also. Now, the basic questions. See, how we are going to proceed with this subject. I am not going to teach simply as like I'm just telling and you are listening, I'm just telling and you are writing. Not that way. Okay, we are going beyond the books. Okay, so that I am going in a so much of depth. Simply reading the definitions, simply you are getting understanding the definitions or writing it, that should not be limited. That that can be a case in case of your second year or third year first sem, but now these things are going to be, or these things are required for your interviews at the time of jobs or at the time of exams. Okay, so now I want the answers from you. If suppose I will heat some material to change the shape of that particular material, if suppose I will heat the material to change its shape, right? So what are the possible changes that are going to happen inside the material? What are the possible changes that are going to happen inside the materials? Or else or else while, because of the heat, whenever we are heating any material, why shape changes? Very basic question. Whenever heating any material, why shape changes? Now answer this question. Yes, you can just chat in a chat box. You can just put your answer. The simple question: whenever you are supplying heat to the particular any of the material, why shape changes? If I will heat the ice, it will melt down. If I will heat the water, it will boil. Okay, getting it? So whatever material it may be, whenever I will heating that material, the shape changes immediately. Shape changes immediately, right? See, any shape of the material, whatever the shape of the material it is having, it is because of crystal structure, because of the bonding with each other. Whatever the atomic bonding is there, because of that particular size of the or shape of the material is there. Whenever you will heat that particular component, that heat is going to disrupt that bonding. Okay, disturb that bonding. Okay, now let's take one simple question. Okay, now see, whenever I used to teach, I used to take the questions on that particular topic, the questions from gate, questions from IES, question from PSU, question from industry. Okay, so that is going to be our approach to this particular subject. Okay, similar way. Now there was a question in a last or 2017 gate. Okay, related to this particular point. Okay, heat and size change or shape change. Whenever you will heat the material, whenever you will heat the particular material, what will happen with density? Whenever you will heat any material, what will happen with density? Simple. Increase in temperature will have what type of effect on the density? Now just give your answers. If I will increase the temperature of particular atom, or if I will heat the particular atom, so that means raise in the temperature, what will happen with the density? What will happen with the density? Tell me fast. Very simple question. If suppose I will heat any material, that means if I will raise the temperature of that particular material, what will happen with the density? Decreases. Okay. Any another? Density decreases. Right. Okay. Density decreases. See, whenever there is a change in the shape of the Na material, density is the major factor behind that. Okay, and this was the question in IES also. In 2014 IES also, there was a question that whenever there is a change in the temperature, positive change in the temperature of any material, what will happen with the density of the material? What will happen with the density of the material? Okay, so temperature increases, density of the material decreases. Density of the material decreases, and and what will happen with the volume of the material? Now tell me. what will happen with the volume of the material? See, connecting links. Temperature increases, density decreases. Now, my question linked with that, what will happen with the volume of the particular material? What will happen with the volume of the particular material? Okay, all are saying that it will increase. All are saying that it will increase. Okay, so that's how the question is asked. Now, in your exam like IES, they are not asking the direct questions, or in exams like PSUs, or in exams like GATE. GATE is mostly now numerical oriented, but conceptual oriented exams are like IES or IAS. In that case, if suppose they want to ask the MCQ, they will not directly ask if temperature increases, what will happen with the density, because there is a direct correlation. They will ask if temperature increases, what will happen with the volume. Okay, rather that this level also not, they will ask if temperature increases, what will happen with the specific volume, what will happen with the specific volume, what will happen with the specific density. Are you getting? Density is different and specific density is different. Okay, if temperature changes, what will happen with the specific density? Now these are the concepts of fluid mechanics, but the questions are asked like this. Okay, so now let's come to the point. So there are some ways by which, by providing the heat, you can change the size or shape of the material by applying the heat. Okay, now the problem is that, see, if you are able to apply the heat, supply the heat, and change the size or shape of the material, why there is a need of use of plastic? Because see, whenever you want to change the shape of the steel, you are having option of supplying the heat and changing the shape, but your objective is only to change the shape. Your objective is not to change the internal microstructure of the material. Internal microstructure of the material. Okay, because see, whenever you want to change the shape of the steel, you are hitting it, you are supplying the heat to that particular material. So along with changing the shape, there are some changes in the internal microstructure also, which is causing to change its properties, like its hardness is there, right? Okay, its hardness is also there is one important factor. Okay, so after heating, some materials are getting soft, and some materials got, they are getting more hardened. Okay, they are getting more hardened. So there are different ways, there are different ways. Okay, now again one more question. If suppose I will heat the material, let's take the example of steel. If suppose I will heat the steel and then I will allow it to cool, what will happen with the property of hardness of that material? What will happen with the hardness? If I will heat the steel and then allow it to cool, what will happen with the hardness of the material? Simple process. I will heat the steel, I will change its shape by applying the pressure, and now I want is hardness. Is it going to increase or decrease? If temperature is increased and then it is allowed to come down to room temperature, what will happen with the material hardness? Getting it? This is how the questions are asked in a maybe competitive exams. In your job interviews, that much of level of questions are not there. Very simple basic questions are there. But in quality exams like SSC is there, staff selection. Okay, UPSC IES is there, engineering services. Sometimes GATE is also there. In PSU exams, they are asking the questions like this. If you appear for the interview of the BARC or DRDO, BRC or DRDO or ISRO, these are the PSUs. That time you will face such type of questions, purely concept based questions, right? These are application oriented question. They were very simple question. Getting it? Okay, so increases. Okay, Okay. We'll brainstorm this type of points, right? Okay, right. So let's come back. So there are two ways to change the shape: heat and pressure. Okay, and the other thing is that whenever you are heating any material, along with the change in shape, there is a change in microstructure also. That is not expected. So that the people have started using the plastic, because to change the shape of, to change the shape of steel, you need to have more temperature. You need to have the more temperature, because again one more concept: if density of material is more, if density of the material is more, and if I have to change the shape of that material, if I have to change the shape of that material, is it going to have a less amount of heat or more amount of heat? A simple question. There are two materials, one is having more density, another is having less density. So which material will change their shape with less amount of heat? Obviously the material which is having the less density, right? Less density. And the material which is having the more density will require more heat. More heat means more change in the internal microstructure. That is happening with the material like steel. So that there is option of plastic, which can change their shape easily with the very less amount of heat, even with the some amount of pressure also, right? So that was, there is a huge applications or maximum use of plastic, because with a small increase in the heat you can change the shape of the plastic, you can change the shape of the plastic. Okay, that's why there is a more applications of plastic. Okay, getting it now? So see, whatever the things I am telling in between to you, if you are having the notebook, please keep that notes with you. See, these things are not directly given in any textbook or any reference book. Okay, these are going to be application oriented things. Once you will go in a more deeper in that particular subject, you will get these things easily. You can also get these things, but need to spend some more time with that particular topic. Okay, so just there are two ways, heat and pressure, by which you can change the shape. But in case of plastic, with less amount of heat and less amount of pressure, we can change the size or shape of the material so that it is having more application. It is having more applications, right? So that is what the plastic engineering. So that's what we are going to deal with, study of the plastic, right? So starting with the history of the plastic, how it is originated, then its evolution, everything, then its properties, applications, processing methods, and testing methods. Because use of the plastic, as I told you, there is a use of plastic starting from toothbrush to the mobile, means from morning to evening. Getting it? So if you say simply plastic, it doesn't mean that it is having a common processing method. Depending on the application, these are having, there are so many methods, because accordingly you are going to vary pressure, accordingly you are going to vary temperature, accordingly you are going to value vary mold designs. Okay, so these points we are going to study in a plastic engineering. Importance of subject, why we need to study the plastic engineering. Okay, so the first point, as I told, ease of processing. Ease of processing. Okay, even if you take a simple small plastic piece with some small thickness, and if you keep it in a open space in a summer days, and if you see it after some time, it may have started melting. Okay, but that happens because processing is very easy at the less temperature also it start melting. Okay, low cost. Now you know this particular application, low cost. If you see all the toys, baby toys, okay, which China is manufacturing, which China is having more market, that entire toys are manufactured with the plastic. In old days the toys are made from the wood. Okay, but after that now it is started manufacturing from the plastic. Okay, diverse applications, as I told, every field you will have the application of the plastic. Unique properties, right? Unique properties, see, it can be easily molded into any type of shape as you wish, with very less pressure, with very less amount of heat. Okay. And good surface finish, so that it is used for, let's take the example of our mobile. Its cover is made from the plastic. Why? The first is glossy surface finish. Getting it? If you see the surface finish, it is a best. So one aspect is a good surface finish. Low density. Again, here that point comes. Low density. Okay. And from last half an hour I am telling that plastic requires very less temperature to melt down. Why? Because it is having low density. Because it is having low density. Got the things? If density is less, you need to have very small amount of heat or small amount of pressure to change the shape. Okay, low density means there is a very weak structure, or the weak bonding between the atoms. Getting it? And last is the heat and thermal insulators. Heat and thermal insulators. Okay, if you see the covering of the electrical cables, it is either made from the rubber, or nowadays you will get it from the plastic. Okay, if you see the high tension wires, high tension electrical wires, okay, in that case you will see the covering is made from the plastic. If you see your electrical boards, if you see your electrical boards in your house, okay, that boards are made from the plastic. Electrical switches are made from the plastic. Okay, so wherever electrical appliances are there, the body is made from the plastic. Just see in your kitchen also, a mixer, right, made from the plastic. A fridge made from the plastic. Okay, so your television set made from the plastic, because it is an insulator, work as an insulator, heat and thermal and electrical insulator. Okay. So, but see, directly you cannot use plastic for the thermal insulator, or because see, it cannot resist high quantity of heat or maximum temperature. So that it should be blended with another material that is called as a plastic composites. Okay, we'll see that also. Next part is the subject objectives. Okay, to know about the applications of plastic, different types of processing and welding of plastic, part design, mold design, okay, cooling system required for the plastic. Okay, see, if you are going to manufacture the plastic, you need to have the mold. Now, in your manufacturing also, you have studied about this particular mold. There you have studied about the casting. Getting it? Casting design or mold design. Okay, what is the mold? Mold is that particular structure where there are some cavities, and in that cavities are a replica of the product. That cavities are replica of the product. So whatever type of product you want, you will have just molten material in, right, and that molten material, when it is poured into that particular cavities, it will form a similar type of product, whatever the size of or shape of the cavity is there. Okay, that structure is called as a mold. So here also similar way, for manufacturing the plastic, we need to have the molds. So that design of the mold also we are going to study. There are going to be some numericals and outcomes. Once you will learn this subject, you will able to know different types of plastic and its applications. Means based on the properties, which type of plastics can be used. Okay, then about plastic molding process and the design of the molds. Okay, so this is our scheme: theory, practical. Okay, so there are practicals also, and you don't have the external oral this for this particular subject. Okay, 70 marks paper, 30 marks internal exam, sorry, ISC, and ICA will be of 25 marks. Okay, these are the topics. The syllabus I have not given in a depth. Once we'll start, I will discuss in a depth about that. Okay. Section 1, Introduction to Plastics, where you will have the basics of the plastics. Second is the processing and welding of plastic. Now you will get confused about this particular word, welding, right? Because welding you have came across only in case of the ferrous materials. Getting it? Okay. But the meaning of welding here is a joining. Joining. Okay. Joining of the plastics. Then design of plastic parts. Okay. In the second section, you will have the design of compression molds, injection mold, and the cooling of that particular mold. Now, some part of this you may have came across the manufacturing also, but their application was different. Your material was either ferrous metal or non-ferrous material, which require very huge amount of heat. But here, mold design is going to be different, right? Because see, based on the temperature of the material only, you are going to design the mold, right? So the mold design procedure is different here. So in the first section, we are going to study about the basics, processing methods, and plastic parts. And in the second section, we are going to study about the numericals based on the mold design and the cooling of the mold. Okay. So these are the some of the practicals that we are going to see, and also there is a industrial visit also. Okay. So like injection molding, mostly there are some numericals based on this mold design. And there is one case study also, whereby I will give you one a plastic product, a sample plastic product, and you will have to design the mold required for that particular product. I will give you the design of the product, and based on that you will have to design the mold. Okay. And there is going to be one visit to the plastic industry. Okay. So these are some textbook. Okay. One more major thing about this subject is that you will not get entire syllabus in any book. Okay. You can consider this as a challenge or difficulty. Okay. But the thing is that there is only one book where you will get syllabus, but it is in a discreted way. You will not get entire syllabus in this particular book, one book. Okay. So whatever the notes I will share with you, you will have to preserve it properly, because for exam purpose or for revision purpose, you will not get entire things in any of the single book. Okay, these are some reference book. Out of that, this is the best one, written by Bradson. It is the plastic materials, and the textbook is written by the Naik. Okay, we are having the copies of it. So, maybe by tomorrow or day after tomorrow, I will share with you the soft copies of these both books. Okay, so that's what for today. So just a minute. Okay, right. Uh, See, just now introductory part we have completed the basic backgrounds, the triple P formats required, right? So as I told at the start only, you will get entire content in a your Google Classroom. Okay, for that you need to do one formality. Okay, so now you will have to share your email ID through which you are going to join this online classes. Okay, ensure that I'm not asking you to put your official email ID only. If it is there, that will be great. Okay, you can easily join with that. But thing is that once you will enter here your email ID in the chat box, you will get notification through email to that particular email ID. Okay, and the notification will be regarding joining to the classroom, joining for the classroom. Okay, you will have to accept that. You will have to accept that, and automatically you will be part of that Google Classroom. And then afterwards, you can access any time whatever the material I will store in that particular Google Classroom. Got it? Okay. Second thing. Second thing is that let me stop the recording. Okay. Second